In a previous video, we went over the WebGPU cross-platform app code by Francois at Google. Hopefully I'm pronouncing that correctly. In this example, we learned that there is some new code for WebGPU. This is the new WebGPU Shading Language, WGSL, or WGSL for short. Kind of has this feel similar to Rust, and I say that mainly because it's got these arrow symbols right here. In this video, I wanted to go over how to write WGSL code in a separate WGSL file, get syntax highlighting, autocomplete, such that you don't have to write raw strings like this. I believe a lot of the graphics programming community said that we were good with languages like GLSL or HLSL. Now, I don't want to get into the nitty-gritty details of why we created a new shader language, but we did. And for that reason, we need to work with it when working with WebGPU. Now, there is a way to write GLSL or HLSL code, convert that to, I believe, SPIR-V and use that, but that's not the most straightforward way. Some really smart researchers over at NVIDIA are also working on another shading language called Slang, which is supposed to give you a lot more of the nice language features that we have in normal programming languages like C++ or JavaScript, such as things like importing other shader files. So this is another way in which you could figure out how to not write WGSL, but maybe write Slang, which will kind of compile down into either SPIR-V, GLSL, HLSL, WGSL for WebGPU, or other languages. One language to rule them all. Am I right? Jokes aside, this actually could be a very useful project. So I'm keeping my eyes on this, but just wanted to let you guys know that there is a way to do it. It just requires a few additional steps. For that reason, we're going to want to figure out a way to just write WGSL code. Now, the simplest way to start with that approach is to create an R string. R string is a raw string in C++. All you have to do is write some shader code, and I'm going to search for shader code. All you have to do is write WGSL code as if it's a raw string, and then set up your render pipeline using that code. All we really want to do is to be able to rewrite this code right here in a WGSL file. I've went ahead and created a shader.wgsl file and just copied the code over. As you can see, writing code in here is much better than writing code in a raw string where we don't have syntax highlighting or any sort of autocomplete. So here I installed the WGSL language support extension. The specific extension doesn't really matter. You could also get this one right here, this other WGSL extension. I use this for a really long time. So either of these probably work well. If I start typing, mat to 2x4, you can get all the autocomplete hints and suggestions like that if you really want to, and that's going to be really helpful. Let's save that shader file, and now let's go back to the CPP. Let's see how can we import this code. We're going to need to create a load file function. Pass in the shader file path. All it's going to do is take in a path. One thing that was interesting for me, I was asking ChatGPT about this, is when it gave me the code, it suggested that I do const string. I was wondering what the difference between this and doing just normal string was. Turns out that it's because we know that the path isn't going to change. So there's no point in telling the compiler that it could change because we know it never would. So if we really want to do, we can make this const, pass in a string reference instead of just a string. A little bit of a C++ learning. Anyway, we're going to create a load file. All we really need to do is return a string. First thing it's going to do is check if it can open the file or not. And if it can open the file, it's going to do this C++ magic. I asked ChatGPT to give me, a quote-unquote modern way to do this, and this is what it gave me. I had no idea what was going on here, but essentially this code right here is reading the file. Here's something that makes a lot more sense. This is the same code, I kind of just expanded it. Essentially, we're taking I believe the iterators at the beginning and the end of the file. Doing this apparently iterates through from the beginning to the end of the file, character by character, put it into this content string, which we can return. So that is pretty much the load file function. So we've essentially went from writing code like this to being able to write our shader code in a WGSL file, which has syntax highlighting and autocomplete. In order to confirm that this worked, I've updated the shader create render pipeline code here. Just printed out old shader code as well as the new shader code. I've already built the app, so I could just run it and it's going to open up this application, but we can close that because we don't care about it. What we really care about is this code right here. In the old shader code, we are printing out the old R string, and the new shader code does contain the WGSL file. So by running this load file function and putting that data into shader code 2, we've correctly loaded this WGSL shader file into the shader code 2 variable. There is one more thing you're going to need to do. When you're passing in the code, you're going to need to convert this into a C string. That's because the shader source WGSL file takes in code, which is a string view, needs to be a const char star, and that's not what a string is. So this, if we go to this, needs to be, a char const pointer. Currently, it's a standard string. We need to specifically convert the standard string into a C string. The WebGPU API is largely written in C, and C expects this type of data, so that's basically why we need that. So first things first, let's just build and run the application, and you've got our nice little triangle here. If you remember at the beginning, we've set our color. So let's just convert this to white. Let's rebuild. I'm going to do make. I set up the make file to rebuild automatically, and it's going to just take a little bit of time here. Before it was I believe a magenta color. I just turned it to 111, which is white. Let's go here. Let's confirm that we're using the shader 2. So shader 2 is the load file from shader.wgsl. So we are currently using this code right here. So currently, if I were to run this, we should see a white triangle. So let's just run the executable, and there we go. We've got a white triangle. That's how you set that all up.